Hey everybody, welcome to the Single Tracks Podcast. My name is Jeff, and today my guest is Chuck Textura. Chuck is a senior advanced concept engineer at Specialized, where he's been involved in countless projects from mountain to road and from bikes to components. Prior to joining Specialized in 2011, Chuck spent 28 years at Easton Bell, where he was the director of R&D. Thanks for joining me, Chuck.
Good morning, Jeff.
So tell us a bit about your cycling background. Obviously, it's a long background, but take us kind of to the beginning. How'd you end up getting into the industry?
Okay. It would start with my grandfather owning a bicycle shop. And my parents, like pretty much parents in those days, making ends meet was pretty tricky. And I was basically babysat in my grandfather's bike shop. So they set up a playpen in there when I was like a toddler. And so I've been like around this stuff forever. And my grandfather was a wonderful teacher, wonderful man. And he didn't have a son, so I was his son, his pride and joy. And he just taught me so much. And at an early age, 5, 6 years old, I was assembling bikes and working on things in the shop. And I just absolutely loved it. And I worked, for him, with him, till my teenage years, until I left home. So that was kind of my gateway into it. And when I was going to school, I was an intern at Easton Sports in 1984, which is an Olympic year.
Okay.
And they were heavily involved with the Olympics. And after the Olympics, Jim Easton was really inspired, and he decided to get into the bike industry. And I happened to ride my bike to work from Santa Monica to Van Nuys, was, 25 miles or something. So they're like, oh, we have this crazy guy riding his bike. We should pick him. So it was kind of just like blind luck. You got to realize back in that time period, America was not a power player in bicycles. I always thought as a young man that if I wanted to get into bicycles, I'd move to Italy or something like that, because even Japan wasn't all that strong at that point. So it was totally unintentional, but it's a perfect fit because it certainly is my secret passion.
Yeah. Wow. That's awesome. And so, it sounds like in addition to working in a shop and like being around bikes and equipment and learning how to work on bikes, like you also rode bikes a good bit. Did you ever do racing or any of that?
Yeah. So I started racing in 1974. And I was a road rider because that was kind of the only thing at that point in time. I didn't discover mountain bikes till quite a bit later. But I raced road bikes for a number of years. And I thought at one point, hey, I'm going to get good enough to be a state champion and maybe a pro and things. And I won the state championships. I lived in Hawaii, kind of a small cycling community. And, very quickly I rose to be the best rider. I moved to California to go to school and continue racing. The level was quite a bit more difficult, but I raced as a Category 1 racer up until 1980. Okay. And I just decided, hey, I better get my act together and go to school and start focusing on earning a living because it was really on the transition of cycling being able to be something that you could really see as a career. The big breakthroughs were just starting to happen, but I had to pull the plug. I didn't think I had the physical ability to do it. And so I thought that was it for bicycles, really. I thought, that was a good thing in my youth. And then I'm going to go to school and I'm going to get a regular paying job. And, when I was working at Easton, it was really more making equipment to do specialized processes for the products that we were making, which at the time did not include bicycles, but very quickly that transitioned into kind of a bicycle career, starting with tubing and then transitioning into components.
Okay. Yeah. And so Easton, I guess, was doing aluminum stuff. Like what they make, I know they make baseball bats. Like, is that something that what were they making at that time?
So at that time, probably their biggest product was the baseball bats, but they did hockey sticks. They did their core product, which started in 1927, I believe, was archery, was arrows.
Huh.
So they are really credited with the inventor of the aluminum arrow, which basically replaced the wood arrow. That went back, centuries, right? So,
Right.
so they were like really experts in aluminum, and they were also getting into composites during that time, because the composite arrow was starting to really come on the scene. And so I worked with them heavily with aluminum and a bit on composites as well.
Okay, cool. Well, yeah, so aluminum is going to be a big part of our conversation here. And specifically, so recently the new Specialized Chisel full suspension mountain bike was announced. And this is a lightweight and affordable aluminum mountain bike that makes use of some interesting new welding technology. Or it's not that new. It's been around for at least 10 years now. So tell us a little bit about this. I believe it's called Smart Weld. How does that work, and what makes it different from traditional aluminum welding?
Okay, so basically, if you really kind of boil it down, if you're building a structure like a bicycle frame, you need a cope or miter, fish mouth, the ends of the tubes, and connect them some way.
Okay.
And those joints are just a artifact of the process of the machining operations to connect the dots, basically, or the tubes together. But it's really not engineered. It's just a happenstance. You need this tube to intersect that tube, and you have to cut a radius and everything. Mm-hmm. So Smart Weld basically is engineering the joints, trying to move the high stress points of the welds away from the highest stress points, or in some cases, combining structures together to either eliminate a weld or move it into a different lower stress area. But also the geometry of many of the Smart Weld interface creates a bit of a V, a little bit of a cavity for the welder to know where to put the weld, to give him a little bit better access so that the quality of the weld can be improved. Okay. It also has a stiffening effect on the weld. So it's basically not accepting the kind of arbitrary placements of the welds, because they really happen to be less than ideal, because all those connections happen to be the highest stress points, and that's really not the best place to weld, but it happens to be the easiest place to weld, which is why it proliferates typical frame construction.
Yeah. So is this a technology or a technique that Specialized developed, or is this taken from like some other area where people are doing this?
Yeah, my understanding is it was something that was developed at Specialized, and it was actually just starting when I joined Specialized. So you might notice it's Deluzio Smart Weld, and that was basically the creation of Chris Deluzio, who still works with us. And he's also an industry veteran, advanced concept guy like myself. Okay. And I just kind of carried the ball, took it to the next level, applied it in different locations. But, he is kind of the inventor. We have a few patents on it, which is why you don't necessarily see it in, other frames or products. But, the concept was, hey, this is not the best place to weld it. This is very difficult, especially when you have bikes with like really short head tubes, many tubes coming together. You have welds piled on top of welds. It's just less than ideal. The downsides, it's more complicated to tool up for, a little bit more expensive, lots of tools for different size frames. So, there's some cost that we have to, take a close look at to see if it applies here or applies there.
Right. Yeah. And so, hopefully we'll be able to share like some photos that really let people understand what this looks like and how it works. But from what I can tell, I mean, the pieces that you're joining together, they're shaped, meaning like we're not talking just like round tube to round tube. And my understanding is, are those hydroformed? Like, how do you get those shapes in the aluminum?
Yes, they're hydroforming, and hydroforming is basically, if you can imagine, like blowing up a balloon, but inside of a cavity. And because the metal does not collapse back down like a balloon does, it basically retains its form. So this hydroforming is done at very high pressure with fluid, and it's basically pumped into a tube that is contained in a steel cavity that has the general geometry and shape that we're looking for. There's a bunch of preforming steps. Budding will happen before, or some swaging, which is a tapering procedure, maybe some bending. Mm-hmm. And then the final, step might be the hydroform, where you basically inflate the tube, you stretch it beyond its yield point, and it touches a steel cavity, a very massive chunk of steel, and it doesn't go any further, and it takes on the shape of that cavity. And those shapes are generally designed for properties needed for the joint or the tube. So the strength requirement might be fore and aft. So the tube is manipulated to get the best out of it. Round's a very efficient shape in all directions. It's the best shape in all directions. But if loads are very specific or very planar, then we can kind of tune the tube into the right shape to get the best properties out of it.
Okay. Yeah. Has that always been around, like since we've been making bikes out of aluminum, or is that like relatively new?
Ooh, okay. It goes back several decades for sure. It's been around quite a while. It'd be very difficult for me to kind of put a date on it. Hydroforming itself has been around in other industries for much longer, late 70s or so.
Okay.
And it's used in all kinds of materials too. I mean, people hydroform steel. There's steel frames on cars and trucks and things not that they use many frames anymore on cars, but they can do some amazing stuff with hydroform steel and aluminum.
Yeah, interesting. Well, so you mentioned that the Smart Weld allows you to move the location of the weld, which improves strength overall. Does it also, what about weight? Like, does this allow you to make a lighter weight frame at all, or is it about the same?
Oh, absolutely. Yeah. So, the thing is, your customer, any bike that they buy, they assume it's strong enough. So to just arbitrarily make the bike stronger, it's like,
right. Well, why would you?
Yeah. Why would you? Why do they care about that? So by making it stronger, it allows us to make it lighter.
Okay.
So we can take the advantage of that extra weight savings by, creating a stronger connection. Typically things fail in those connection points. They might fail at holes, or, it's like anything that any discontinuity in the structure causes a concern and a potential place that, you're going to see a failure. So when we enhance a connection, then we can basically take material out. And because we pretty much shoot for a known durability need based on what the bike is likely designed for or going to be used for. So, a cross-country bike certainly is tested to a standard that's applicable to that, and a DH bike is tested to a completely different standard because the use case is dramatically different. You would think of it the same as a semi-truck versus a pickup truck, right? I mean, totally different beast. But yeah, the Smart Weld allows us to take some of the extra weight out of it. And anytime you're kind of tuning the structure for efficiency and weight, it comes at expensive time and development, and also cost because of tooling it becomes a little bit more complicated.
Yeah. Is it still overall though, like compared to say a carbon frame, because you're using aluminum, is the cost comparable? Is it a little bit less?
It's quite a bit less. I mean, carbon frames have an insane amount of handwork, right? Every ply is laid down by hand. The materials itself is very, very expensive. Aluminum is, by contrast, is far less expensive. The steps and time to produce it is probably a little bit less. Energy consumption is a bit less. From a sustainability standpoint, aluminum definitely has an advantage from like a recycling perspective and so forth. So I think, aluminum brings a lot to the table. And I in particular am very passionate about aluminum bikes because of costs. So when I was a young starting racer, bikes weren't that expensive, and I could, as a minimum wage bike shop employee, I could buy a competitive race bike pretty easily and go and race with the adults who had the latest and greatest, and feel like I was on equal footing. In today's era, I just can't imagine a guy working in a bike shop throwing down for an S-Work bike and to go and race with somebody, So I really love the idea of having a chassis that's affordable, and then you can soup it up with some great parts, and maybe you're a pound or two behind the guy with the top shelf product, but it's not enough to really make or break your event or your results. So I'm super passionate about it, because I think in my day we raced Mustangs and Camaros, not Lamborghinis and Ferraris.
Right. Well, we were talking before the recording here about the new Chisel full suspension, and you mentioned that was under development for quite a while. And I believe before that, though, there was the Chisel hardtail, which has this smart weld technology in it. Why haven't we seen more specialized mountain bikes with this smart weld aluminum?
It's always a balance of the objectives of the end product, and we only apply it where it's going to give us the best value, give the customer the best value. So if we don't see its application and saving weight or increasing the performance of the bike without having the costs spiral out of control, so it's just used kind of sparingly and surgically, just so that we don't overuse it and so that we don't drive the cost. Because at the end of the day, you're really trying to, when you're making an aluminum product, you're really focused a lot on that value versus weight and performance. You just whereas carbon is just like all in for the best, lightest, everything. And with aluminum, that would be kind of a challenge for most customers to absorb, because they would look at it and say, wow, this bike's 100 grams lighter than this one, and but it costs a lot more. It's a complicated equation. I personally would put more in, but then it would drive the cost up, and it would probably make the product not jump off the shelf like it.
It seems like a consumer education challenge. And I noticed too that there was a road bike, the LA, that had smart weld, and Specialized had like a S-Works, the full like top of the line version, but it seems like it didn't stick around. I mean, was that part of the challenge, that consumers were like, like this is like top of the line, but it's aluminum?
Yeah. Well, I couldn't speak to why it's here or not. I personally have one.
Oh, cool.
And I was heavily involved in the LA Sprint, which heavily used a bunch of smart weld on it. And I had some of the previous LA smart weld bikes, and they're an excellent bike. But I couldn't really speak or understand why those things kind of drift into the market or not. But I think part of it is an educational thing. It's like you just don't really know how good it is until you actually own one or ride one or experience. Just basically experience the platform. So it's my go-to bike at work. I still ride one with rim brakes and red components on it. So
yeah, that's awesome. Well, so there's a video of you, and I think this is around the time that the LA S-Works came out in 2013, talking about how until that point, like aluminum had kind of been brushed aside by carbon fiber in the bike industry. And now, I mean, that was 11 years ago. Do you think people are still overlooking aluminum, or have things changed? I mean, I feel like for us in the mountain bike media industry, every year we're like, oh, I think this is a trend. I think we're going to see like more high end like alloy bikes, and then it never really catches on. So do you think that's always going to be the case, or things possibly a little bit different this time?
Well, we are continuing to invest in better and better aluminum bike technology. So I would say it's definitely going to continue. We have not taken our eye off that ball. as carbon is basically increasing in price faster than aluminum. And, again, so much of the decisions and the technology that's put in is based on value. So as that delta increases, it allows us to invest heavier into the aluminum product and not brush it aside. But yeah, less emphasis has been put on aluminum product as a result of, just really focusing resource on the top shelf product. But aluminum's not a stepchild, and they are definitely, the company as a whole has really upped the ante. I'm currently very actively working on a very big development project on exploring what's on the table, what's left, what approaches we can take to making our next aluminum bikes ever better.
Yeah.
And, a big part of the company's focus is driven by sustainability. So, it's something that's very appealing to us. It's appealing to the world. And there's a lot on the table. It's just a question of what the market will understand and what the market will appreciate. So I think some riders maybe underestimate how good an aluminum product can be. And we're working on the educational part and also the technology part, because kind of the scale kind of drives that, right? They look at it, and in the case of rims, aluminum rims are a solid item, right? They're a go-to product, right? They're not seen as something poor or low end. Yeah, sure, you can have carbon rims that are lighter and extremely strong, but aluminum has a very solid footing there, and that really kind of speaks to design and application, and that's the other coin, or the side of the coin, of the smart weld type of technology. There's a lot left on the table, and it's not so much the metal or material that it's made out of. It's the application. It's the design of the structure, because you can always keep wringing more and more out with application. So I think back, I'm an old guy, so I think back to the very first carbon bikes, and they were made with steel or aluminum lugs, and they were bonded together to kind of look like their steel counterparts. And they were terrible. They weren't light. They weren't strong. They weren't even stiff. I mean, they delivered kind of nothing, but they sold because they had a perceived technology. And they got good when they became uniquely carbon in their construction, in the sense of being molded one piece. The material, the fibers and the resin, very, very little change from like the 60s. But it's the application, right? It's the engineering, it's the design, it's the process that makes it better. And I stand firm on that with any product made out of anything. It's when you really understand the nuances of the deliverables, and the nuances of the material and the processes, and you can wring out so much if you just pay attention to those details. And that's like a really weird concept for most users, because they really want the material to be the hero.
Right.
It's very nebulous to say, oh, well, it's designed this way or it's tweaked this way. That's a little more difficult to understand. But the truth of the matter is that's where the most meat on the bone is, to that fine understanding and fine research into design and application, because a lot can change as a result of that.
Yeah, definitely. I think you're right, because there are, bikes are complex, and like whenever you're going to buy a new bike, there's so many things you're trying to take into account. And for a lot of us, shorthand is like, what is the frame material? But I think the takeaway is just, material plus design. Like, just at least consider that, like when you're looking at a bike, and understanding, like, is this a good use of that material or not? And I will say, for me too, as a consumer, I bought a new full suspension mountain bike last year. And I went with an aluminum bike because of a lot of the advantages that you listed off. And I'm also running aluminum rims on my wheels. And so I want to talk too about wheels a bit. You were involved in a release a few years ago of the Roval Control SL rims, and these were carbon fiber, I believe. Maybe there's an aluminum version now, but one of the big innovations I remember at the time was this idea of a wider bead profile to prevent pinch flats, or at least reduce the number of pinch flats that you might get. How did you and the team come upon this design?
Yeah, that's a pretty probably a pretty long path, and it really, I think it kind of connects into think about how the smart weld technology relates to it. So just keep that in the back of your mind.
Okay.
So the hooks on rims, or the sidewalls on rims, if they happen to be hookless, typically mountain bike rims have been hookless for a bit of time now. Mm-hmm. They only need to be a certain width to hold the tire on, and a certain strength to hold the tire on.
Yeah.
That's their primary function. And I recognized that aluminum rims or wheels, they didn't pinch flat as easy because they dent, and carbon rims don't.
Okay.
And these very thin rims, which were wide enough the hooks, the beads of the rim, they were wide enough to hold the tire's pressure, but they were kind of thought of it as a singular function. And I got to thinking about the geometry that we used and why one worked and one didn't work. And it was just like a crazy question. You know, I've always had this weird notion of trying to look around the corner to find some kind of secret. And it's just been a little bit of a knack of mine. So I was curious. So I actually made a special rim with 16 different shapes for the hooks.
Wow.
Shapes, widths, some that were like a lollipop, just a full radius, some that were very square on the inside, round on the outside, 16 different variations.
Wow.
And we have a impact tester that's created pinch flats, and we tested various pressures, various drop heights, and multiple times to make sure we stabilized the data. And we clearly saw a trend that this geometry was dramatically different. And, carbon rims are quite light, so you can kind of invest in adding maybe a little bit of weight to the rim. Now, the hook doesn't need to be that wide or that flat to hold the tire on, but we started thinking about it as a secondary purpose or secondary feature to kind of reduce the sidewall cutting or pinch flatting. And it was like, wow, we are doing this, and it wasn't an epiphany, but it like totally made sense. But we didn't guess at it. We knew it. So we knew when we made that wheel that we would do better.
Right.
It was just an absolute given. And then the Traverse rims are even wider still, and it's kind of a weight decision, right? The trail rim can be a little stronger, it can be a little bit heavier. The customer is okay with that; they expect that. The cross country racers, they can accept something that's a little bit maybe less protective, but still protective enough. So the key is it's just like a downhill frame versus a cross country. It's like the appropriate weight and strength for the application. So that's kind of how that evolved. And it was just like, well, this shape is kind of arbitrary. It came from an aluminum dimension. It was thick enough to hold the tire on. So it's got to be good, right?
Yeah.
Well, that's just maybe falling a little bit short of thinking the entire problem through. So, and then, doing this experiment, it was just like, oh yeah, this is really good. So, I'm pretty excited, pretty proud about that, because that is the biggest buzzkill, right? Going on a ride and, you gotta wait for your buddy, or you're the guy with the flat, right? It's like, geez, so I'm pretty stoked about.
Yeah. It's such an awesome
story.
finding. And you mentioned too that like this added a little bit of weight to the carbon rims. But then I remember like at the time and, attending presentations about the wheels, like part of that trade-off though was like, hey, maybe you can run lighter weight tires because you don't have to have these sidewall protected like overkill tires now. If you're worried about pinch flats, now you can go back to those like lightweight XC tires. And so, yeah, thinking about like the whole system seems to really pay off.
Yeah, I actually have a philosophy, and it doesn't really pan out. The technology is not there, the behavior is not there, but the pressure in which you run in your tires should not be driven by, if I run that pressure, I'm going to get a flat.
Which it is, yes.
Which it
right,
is.
for all of us. Yeah.
I don't accept that.
Yeah.
I don't accept that. I would like, in a perfect world, you run the pressure that you need for the traction, the ride experience, the bump absorption, and it doesn't flat.
Yeah.
Wouldn't that be a wonderful thing?
Right.
That's my goal.
The Holy Grail.
I think about that every day because, and yeah, getting there is really tricky. But to me, we have not done it all if we haven't got there. But that's truly what I believe. It's. I think other vehicles, you run the pressures that you need.
Right.
I've talked to like really fast guys, it's like, can you ride your bike with reckless abandon, without fear of something breaking or flatting, or do you have to like check up? And if the answer is no, then we got work to do.
Yeah. There's an opportunity.
That's my energy. That's where my head goes, because, most people don't push their product to that limit, but the pros certainly do. Even your fast weekend warriors, right? They push things to that. And how I can ride my bike as fast as I dare, but that's not at the limit of the product. So the product needs more if the fast guys can use more. So that's what keeps me inspired. That's why I come to work every day. And that's my mission.
Yeah. Well, I think even those of us who are not pushing things to that level, we can all relate to the tire pressure example. And so, yeah, I mean, just not to take a huge detour, but like, what are your thoughts on tire inserts? Like, is that a good solution for running the pressures you want and not worrying about flats? Or, I mean, it sounds like you're saying there's something else out there that we haven't found yet.
Well, certainly inserts work. There's no denying that. They come with some weight and some nuisance from an installation standpoint.
Right.
So one of the things that I don't love about bicycles is that they're very nuanced. They're very finicky. They really play to experts. And I like bringing more people into this great activity. And, if you can take some of the nuance out of it, the nuisance out of it, I think that's a win. And, inserts, yeah, they work, but I think there are better ways. And, since people have already got inserts out there, I don't work on inserts. I think of other ways to do it. So I don't want to talk smack about them because they for sure work, but everybody knows they're a little bit of a pain, right? To get your tire on, especially the heavier, thicker, stronger your insert is, the more difficult it is and the more weight that it adds to the product. So yeah, my head and my focus really goes to, it's like, I believe there's better solutions, and I spent a bit of my time on working on that, but yeah, I don't have an answer for it at this point. Right. But I'll share a little old time story at the very first World Championships, UCI Mountain Bike World Championships, Durango, Colorado, 1990. I was there, and I was working for Easton, but I was working very, very closely with the Yeti team at the time. And I had been really instrumental in getting their direction set on their carbon steel C26 bikes that they were racing. And Julie Furtado and John Tomac were our top U.S. riders, both riding Yetis. And at one point early on in the race, John Tomac and Julie Furtado were leading the World Championships. John Tomac flatted, and he eventually finished fifth. Ned went on to win. Ned probably would have rode Johnny down because Johnny was a notoriously fast starter, but who knows? Right. But But John flatted. The fact is, John flatted it, and for sure he wouldn't have finished fifth. He may have finished second. He may have finished third, but for sure he wouldn't have finished fifth. But a flat, right? And Johnny ran high pressures. It was the tube era. Julie went on to win, which was amazing, on a bike that I personally glued together for her. But yeah, flats, you know, I mean, they changed the complexion of things. It's like, wow, how many pro races have been decided? And, you know, now the World Cups, right, they have pits to change tires and things because no one wants to see a rider lose an event, you know. And in 1990, John had to fix the flat by himself. And if anybody handed him a tool or touched anything, he would have been DQ'd. So, you know, it's a different era. But even in your day-to-day rides or trips, it's like flat tires.
Yeah.
I think it's the biggest thing that keeps people off bikes. Like, say a family of four wants to go for a weekend ride. They go to the garage. They look at the bikes. One has a flat.
Yeah. It's 8 tires. One of them's bound to be low or flat.
Yes.
Yeah.
Yes. What a buzzkill. You know, it's like we got to figure this out.
Yeah.
And yeah, I think there's still a lot there.
Yeah, I'm with you for sure. And though, to be fair, I mean, tires and wheels today are leaps and bounds beyond where they were in the 90s, certainly, but maybe even 5 or 10 years ago. But when we're talking about mountain bike rims specifically, what do you think? Is there a clear winner when it comes to material choice, carbon fiber versus aluminum?
You know, I would say that's a pretty difficult question because they both have their strengths and weaknesses. You know, for sure, aluminum rims, very affordable, replaceable, repairable. You can bend dings out of them. You can beat them back straight again. They deliver, you know, tremendous value and durability. Carbon rims are more expensive and they're certainly lighter. They deliver a different ride. I think both deliver a great ride, and I think the camps are pretty divided. I think some people really love the ride of an aluminum rim, and some people love the ride of the carbon rims. And you know, so you know, it's really kind of a personal choice. But yeah, if you're really shooting for the lightest type of product, you know, carbon, it's kind of a clear winner. If you're looking for something that's more value, more robust, more repairable, you know, the aluminum rim kind of wins out. You know, there's certain things, you know, if you're speaking to the road market, right, with aero rims, right, it's something you cannot do with aluminum rims without them getting way too heavy. So, you know, clearly those deep dish aero rims, carbon is 100% hands down.
Yeah.
The winner.
That makes sense. Well, yeah. You know, I'm fascinated by the story of the rim bead wall and the pinch flat discovery, like that kind of stuff. And clearly you're excited about it too. So I'm wondering about, like, are there other stories from your career of products or designs that stick out like that, where it's like a huge, like, aha moment where you're like, wow, this is really cool.
Yeah, maybe there's a couple. You know, again, I've spent the greater percent of my career working on aluminum, and early on, I want to say maybe in '86 or something like that, we did tubing for Trek and Raleigh bicycles when I was at Easton, and everything was straight gauge, including all of the welded Cannondales and Kleins. They were straight gauge aluminum, and the belief at the time was aluminum bike is heat treated after it's welded. Ergo, you have no heat effective zones, so you have no need to butt the tubes. Especially true on a bonded bike. There's really very low heat involved. And typically it was understood or believed that the steel bikes that were butted because you would lose some properties, which is true when you weld it. But the other point of the equation is the structure, no matter what it's made out of, no matter what its heat treat condition, the joints are always the weak point. Right. Kind of like the smart weld type of thing. So I recognized it's like, wow, aluminum really needs to be butted like the steel. But my big contribution and it also spilled over into products, was recognizing the dramatic difference in strength requirements in a weld or in a joint versus the middle of the tube. So steel bikes are butted, and I don't have the numbers off the top of my head. I used to know this kind of stuff, but there's a minor difference in thickness from minimum to max.
Okay.
And it's perfect. It's appropriate. It's well thought through. Decades of smart people have kind of evolved it into the appropriate ratio.
Mm-hmm.
But the ratios needed for aluminum is far greater. So I was kind of the first guy to recognize this, and I would make tubes that had tubes that were 3 times thicker in the high stress than in the thin section. So they were like paper thin in the thin wall sections and quite thick and robust in the weld areas. And, just kind of a farm boy approach that I took to this. It was like, okay, these aluminum bikes are this thick and they're failing. So I'm going to make them thicker because that's clearly not good enough. And then in the thin wall section, I'm going to make them as thin as humanly possible.
Yeah.
And that's exactly what I did. And all of a sudden it's like, wow, not only are these bikes stronger, but they ride better. Because I took a bunch of the excessive stiffness out of the bikes. And now the frames had a little bit more liveliness and springiness to them. And I remember presenting this to Trek on their bonded bikes, and they were like, oh no, these are bonded. They're not welded. We don't need to do this. And I'm like, guys, I can take a 1/4 pound out of your bike, a 1/4 pound out of your bike if you just do this. And the tubes are free. Here they are. You just glue them in the bikes and you let us know. They loved them, put them in the product line, and, kind of never look back.
Did you ever take things too far in any of the testing or the prototyping? Like, did you find the point where it just bends right in the middle?
Oh, yes. Yeah. I definitely had pushed it to the point where dents and buckling became a little bit too far. But I used that same approach with it's really my second product, but I worked very closely with Answer. Answer Products was right up the road from Easton, just like Yeti was not far away either in the San Fernando Valley area. And I initially did their taper light handlebar. I think it was maybe 87 or somewhere around there. And they wanted to push the bar even further. And that's when I did the Hyperlight for them. And, that bar was thicker in the clamp zone where all the bars failed than any aluminum bar on the market. And then it was paper thin. It was 0.8 millimeters at the ends, because when your hands are on grips, there's no strength requirement there. Now, if you talk about pushing it too far, if you crashed on your brake lever, you could kind of crinkle the bar a little bit. If you were using bar ends, which were very popular at that time point, and crashed on your bar ends, you could definitely wrinkle. So I definitely was always very edgy, pushing things to the limit, but the failure modes were somewhat in a ductile manner. So I think those were that was like a really landmark thing. And that the experience with Answer on these bars, they were more of a motorcycle company getting into the bike industry at the time. And they asked me, they were like, hey, the magic that you're doing with these bike bars, can you do that with a motorcycle bar? And I said, I think about some ideas. So I, went back to work and thought about some things. And I came up with the idea of this no crossbar bulged motorcycle bar. It's called the Pro Taper. It's a widely used platform now, and there's no crossbar on it. And I walked this thing into their office, and I had 2 versions. I had an 1/8" version, I had an 1¼ version. And on a coffee table, basically, they're like, oh man, that one's way too fat. We can't use that. Hey, it's stronger and everything. No, just visually, it's like, no, it's polarizing. We can't do that. But the 1/8", we're kind of interested. But then they said, this is not going to work. We need a crossbar. It's not going to be stiff enough. People have done a 7/8 solid aluminum bar, and they were strong enough, but they were noodly. Nobody could ride them. They didn't. I know. No, trust me. This is better. This is using I actually did some very early FEA on this thing, and I did a bunch of hand calcs. And I'm like, this, test it. And they loved it. They recognized it was patentable, and they put that thing on the map, and they did all the hard work getting that thing to market. But it was basically using those same principles, the same material manipulation, the same application, which has really been the foundation of all the work I've done. It's just really getting into understanding the application, material, location, needs, and taking the material out where it's not needed, putting it back in where it is needed. Sometimes you don't want to get overly greedy, right? It's like, I'm going to invest in the high stress area. I'm going to make it even better.
Right.
And I'm going to take it out of the low stress area. So it's that kind of, and in carbon, it's really easy to do because you're working with plies, right? You can just put a ply here, ply there, and just build things up. With aluminum, it's a little bit more complicated to have the tooling and the ability to manipulate the shape and move the material around to do it. And it takes a lot more work, a lot more tooling. And, if you get it wrong, it's harder to make a change. With a layup, you just simply put more in or change the ply angle or something. It's a little easier to recover from, maybe a misdirection or a mistake.
Right. Yeah. Yeah. You mentioned that one of the concerns or part of the feedback you got from Answer was that the bars just, they looked weird or they looked different. And obviously aesthetics are a big part of any product. Does that frustrate you as like a designer and engineer that you're like, no, but this is better? And they're like, I mean,
absolutely.
Yeah, still, even to this day, like I can imagine as a young engineer, it's like, yeah, you really have a chip on your shoulder and you're like, no, but yeah, still, even today, that's still frustrating.
Yeah. So I was far less tolerant in my younger years, but I grew to realize how important the look of the product is and how that really speaks to a customer, and to work in a place that it's a choreographed dance and a little bit of compromise to make sure that everybody wins in that, because it's seldom all one way,
right?
And that's just typical of a young person. Is you're very bullish on it. It's like, no, it has to be this way. And it does. And truthfully, it has stymied many products. So again, just going back to old stories, when they first made the very first aluminum bikes, they had the same diameters as steel bikes. When they made the first tie bikes and carbon bikes, they had the same diameters. And those products did not deliver the performance because designers, engineers at that time, they didn't have the freedom to change the geometry of the tubes. And consequently, they had their hands tied. They could not make that product perform. And aluminum bikes got good when people like Klein and Cannondale started making them bigger. But the people of the era would look at those bikes and go, that's ugly. That, a 50 millimeter tube? No, that's unacceptable. But over time, our eyes adjust to it. And when I look at my old bikes, they're pencil thin and pinner, and that's appealing to my eyes. But I also have learned to accept the bigger geometry, because that's really important in making the structure hold out. I mean, I've always been a tech weenie geek about products. And in 1975, I bought a titanium road bike. They made them back then, but they were really driven by the dimensions of the steel product. And they were very light, but they were super flexible and they were not strong. And I, as a 115-pound junior, I rode it for a year and broke it.
Oh, geez.
It just didn't hold up. But I loved it. I actually still have one. I bought another one years later. But people, and then the material goes away because people are like, the material is no good. But it was the design that was no good, not the material. Once the design changes, then the material can actually do its thing. They made aluminum bikes in the 30s, but they weren't that durable because, their design was really kind of locked into a kind of a steel dimension. So, and that's a challenge if you're working with a industrial designer, because they have their finger firmly on the pulse of the look,
right?
And I've totally learned to respect that. However, there's just certain things you can't do with certain materials. You could make an aluminum chain, but it would be giant.
Right.
You couldn't have any gears on the back of your bike. So the right material for the right application is important.
Yeah, that's a great lesson. So yeah, you're mentioning a lot of these great older bikes that sounds like you still own a lot of them. But I remember reading in 2020 that you lost your house in the Santa Cruz mountains to wildfire. How have you recovered from that? Were you able to at least keep some of the bikes? It sounds like maybe.
Yeah. So well, of course, I had way too many bikes. Well, not way too many bikes. I had a lot of bikes.
Yeah.
I don't know. I had something like 45 bikes.
Okay.
And but the good thing about bike racks is they can only carry bikes.
Mm-hmm.
And I was very fortunate that we were able to do 2 evacuation trips.
Okay.
So my truck had a bike rack on it, or that I could put on it, and then our car actually had spots for six bikes.
Okay.
So I did two trips with those bikes, plus a couple of little bikes.
Is that all you were getting? We're like jumping right to the bikes. You're like, as long as I get the bikes, it's fine.
When you're faced in those circumstances, the priorities rise to the top.
Yeah, and that was literally your priority, was the bikes? That
was one of my priorities, yes. Also, oddly enough, sew-up tires were, because those vintage bikes, that's the tires they use. Yeah. So, I grabbed a bunch of those. Yes, and they're getting harder and harder to access. So, to answer your question, we have fully rebuilt our home.
That's great.
And, we just because I'm just that kind of guy, we actually had permit number 1 in the whole 980 homes burned. And I had permit number 1. I was the first to actually complete the rebuild of the house.
Wow.
But, recovery is kind of an interesting term because, yes, we rebuilt very, very quickly, and we're back in our home. May 5th was actually 2 years that we were back. And so we recovered really fast, but the rest of the community has been very slow to rebound. The news recently stated 1/3 of the houses have been rebuilt, but that's greatly exaggerated. Maybe 1/3 of the people have got permits, but they're not actually built in their home. So I was very fortunate that my property, a flat lot, that everything cleared, all the cleanup went pretty well. But there's a lot of things to put back into place. There's a lot of areas where the insurance falls short. The actual building of the house, we did pretty good with that. But your personal possessions, your landscaping, all those things, So the lesson learned is make sure your insurance matches your collection or your possessions.
Right.
And mine, I had squirreled away decades and decades of old bikes and parts and tools are the big the big loss. Those kinds of things. Yeah, you just can't possibly evacuate. But I'm very grateful for what I did choose. I think I made really great choices. There's only maybe one thing I can look back on and go, dang, I really wish I would have made the time to get that. But you do have limited time and so forth. And but emotionally, it's still has scars. I look around and the dead, burnt trees and things that I have to look at every day. They do remind me of a little bit of sadness of the event. But the bike industry, a coworker of mine, good friend of mine, Dave Costa, set up a GoFundMe, and that helped a lot with some of the shortfalls of the insurance. And I just simply didn't know. I was uninformed in the fact that I didn't look at my policy and and carefully scrutinize it. And when we moved into a rental place, we had rental insurance. And I asked my wife, I said, oh, I wonder what that covers, And we checked. And even the evacuation bike collection exceeded the coverage of it.
Yeah.
And I was like, we got to step this up,
Wow.
So, just even just for theft, right? It's like, you just need to pay attention to what the contract says. And it doesn't cost a lot to boost it, but you've got to be informed. So,
yeah. That's
shout out to that information.
Yeah, that's great advice for sure. And glad that you've at least restored some of what you had before. And recovery will take time for sure.
Yes, it will.
So as someone who has lived and breathed bicycles since the 80s and really before that, is there anything that surprises you today about bikes, and what are you stoked about right now?
Wow. Yeah. The bike is dramatically different. And since I'm still passionate about my old bikes and I still have a lot of my old racing bikes, I'm absolutely astounded by how light today's bikes are, how durable they are, how less nuanced they are in some ways. Some ways they're a little bit more nuanced, but shifting is it's beyond my wildest dream. So how good shifting is. Shifting is just mind blowing. Cable shifting got to be really amazing, and electric shifting has just become just totally next level.
Yeah.
Full suspension mountain bikes now weigh less than the rigid bikes that I rode.
Right.
In the early 80s, which is just amazing. Tire size, traction, the terrain that you can ride over. It was like we were happy to survive fire roads, basic fire roads almost, compared to what people ride today. So, the capability, both road and off-road. I think off-road probably made the biggest strides, the biggest changes, and so forth. Suspension, mind-blowing. Dropper seat posts, kind of a game changer in your riding technique and ability. For sure the brakes. There's probably not an aspect that doesn't just completely shock me. Suspension was put on bikes a long time ago, but it was like, oh, that is so heavy, and who would want to pedal up a hill with that, and it's bobs all over the place, and that is so far from the truth now. So I'm truly astounded, and you can only appreciate how good a new bike is if you go ride an old one.
Right, that's true.
It's like terrifying by comparison. So I'm really impressed, and even on the equipment side. When I started racing, you had to nail your cleats onto your leather shoes.
Oh wow!
You had to be somewhat of a cobbler. You had to figure out where they went. Wow. And you had one chance to nail them in right, and if you nailed them in wrong, it was really difficult to actually move them. But it was really hard. The clothing has gotten so much better. It was like, we didn't have windbreakers and knee pads and good gloves and such. So, the helmets, all this. There's probably not an area that hasn't made the experience a little bit more pleasurable, with the exception of maybe the cost.
Right.
To get into it, the kind of the barrier.
Well, given all those improvements, is there much room for further improvements? Or are we going to see, you think, smaller incremental ones, or is there room still for some big changes?
I gotta believe, given the progress that I've seen, that yes, there has to be. I think I would be foolish to sit back and say, oh yeah, that's about it. Did I ever think that there would be 12 cogs on the back of a bike? I grew up with 5 on the back of the bike. So, so I wouldn't leave anything short. And I think, just as I was saying earlier with the tire pressure, we're not done. There's problems to solve. There's ideas to vet. There's technology, materials, maybe batteries, downsizing, your electric shifting on your bike, or smarter suspension, smarter tire pressure management. I think there's lots of areas where the bikes are going to get more sophisticated, much better, much faster, much lighter. I definitely, maybe you won't see the huge swings. Mm-hmm. And when I got into it, you could take a pound off a bike and not compromise anything. And it was like, yeah. And you're not gonna see that kind of swings with the current materials that we're working with, but you definitely will see an edging up of that. I firmly believe that, because there's definitely a lot to do.
Awesome. Yeah. Well, Chuck, thanks so much for taking the time to chat and share your stories. Yeah, you've clearly been involved in a lot of really exciting, interesting projects over the years. And you're a treasure. So thanks.
Well, thank you. I feel super fortunate to have landed in the spot that I have, and I've made a career out of it. I never first saw that as a young man. I thought bicycles was something that I was going to have to kind of put behind me as more of a hobby, and I'm thrilled and blessed to have been at it for as long as I have. And I continue to appreciate it and be passionate about it.
Yeah, that's awesome. Definitely an inspiration. So if you want to learn more about some of the technology we talked about here, we'll have a link to the Specialized website, and also hopefully some photos as well in the show notes so you can see some of the things we were talking about. That's all we've got this week. We'll talk to you again next week.